Based on the discussion, let's try to solve example problems. I'm gonna give you two example problems. So the first example problem gives us the numbers sigma x, sigma y, and tau xy, and it asks us what is the principal stress and principal axis, and it also asks what is the maximum shear stress and the axis that corresponds to maximum shear stress. Okay, so if I visualize the stress, we have normal stress in tension in x direction and compressive normal stress in y direction, and we have 40 GPa, 40 megapascal. It must be MPa, 40 megapascal shear stress. Okay, so given this kind of setting for original xy coordinate, the problem asks us new coordinate system such that we have purely normal stress state, which is principal stress state, or the maximum shear stress state. So the first thing we have to do is we have to draw Mohr circle. So to draw Mohr circle, we have to know the average stress. So the x direction we have 50, y direction we have negative 10. So average normal stress is 20. Okay, so the origin should be 20 and 0. Regarding the x, it's sigma x and negative tau xy, it's 50 and negative 40. Y, in sigma y and tau xy, it's negative 10 and 40. Okay, so these are 3 points that lie in one line, and they out of these 3 points we can make the Mohr circle. In addition to that, we can also obtain the radius of a Mohr circle from sigma x minus sigma average squared plus tau xy squared and square root of this sum. Okay, and it gives us 50 megapascal. Okay, so based on these three numbers x, y, and o point, we put x point, which is 50 and negative 40. We put y point, which is negative 10 and 40, and we put o point. O point is 20 and 0. Okay, sigma average and 0. Okay, so out of these 3 points, we can locate the principal axis and maximum shear stress axis locations. So principal axis occurs when we have 0 shear stress and maximum and minimum normal stress. So if you rotate this 2 theta p degree in the Mohr circle, we're gonna have sigma xp and yp, the new points. Okay, at this axis you have sigma xp equals to be 70 because it's 20 and 0, and the radius is 50, so you have 70 and 0, and this new point, 20 minus 50, which is negative 30 and 0. Okay, so at principal axis it should be 70 and negative 30. And how can we obtain this 2 theta p? 2 theta p can be obtained quite easily. So if you consider this, the coordinate of x is 50 and negative 40. So you can see that the height is 40, and you have 50 here and you have 20 here, so the horizontal length is 30. Okay, so it means that tangent 2 theta equals to be 4 over 3. Then I think it must be 4 over 3, and out of this 4 over 3 you can obtain theta p. 2 theta p is 53.1 degree. Okay, so this is 53.1 degree, and out of this you can obtain the rotation angle of the coordinate system x prime y prime out of this relationship. So theta p must be 26.6 degree. Okay, so if you define like x prime y prime by rotating this 26.6 degree counterclockwise according to x prime y prime coordinate system, you're gonna only have pure normal stress and pure and 0 shear stress. Okay, and the degree of normal stress is 70 and negative 30. You have 70 in tension, negative 30 in compression along y prime, and 0 stress in normal shear component. Okay, so that's how we obtain principal stress. Regarding the maximum shear, you can either do clockwise to theta as here, or counterclockwise 2 theta s there. Okay, so yeah, typically the relationship between 2 theta p and 2 theta s is plus 90 degree. Okay, so starting from 2 theta p, if you add up 90 degree, it's same as 2 theta s. If you divide 2 in left hand side and right hand side, theta s equals to be theta p plus 45 degree, and theta s turns out to be 71.6 degree. Okay, so after rotating 71.6 degree, what you're gonna get is, the normal stress along x prime y prime will be same, and you're gonna have maximum shear stress. Okay, so how can we obtain that? So at these 2 points where we have maximum value of vertical component, yeah, so you have simply the radius, which is 50. Okay, so the shear stress will be 50, and the normal stress will be 20 and 20 here, because sigma x prime and sigma y prime, yeah, should be same as sigma average, as I told you in previous lecture. So yeah, you have simply 20 megapascal tension, 20 megapascal in tension. You're gonna have negative tau x prime y prime, and the value of negative is 50. Okay, so yeah, you're gonna have a maximum shear stress of 50 megapascal, and yeah, you can have normal stress x prime y prime as like a 20 megapascal. That's the coordinate where you have maximum shear stress and normal stress component in x prime y prime are equal to each other. Okay, so you can answer the problem 1 in this way when this problem asks principal stress and axis and maximum shear stress. The other kind of problem is, instead of asking principal stress and maximum shear stress, the problem asks you, the reading in new coordinate system after telling you the rotation angle first. Okay, so this problem asks you in this way. So given xy coordinate system, the reading is sigma x, sigma y, and tau xy is given as 100, 60, and negative 48. Now, if somebody define new coordinate system like a 30-degree angle rotated from the original coordinate system x prime y prime, what will be the reading? Sigma x prime, sigma y prime, and tau x prime y prime. Okay, so to answer this question, we have to first construct the Mohr circle. X is sigma x and negative tau xy, 148. Y is sigma y and tau xy, 60 and negative 48. Yeah, and sigma average is out of this 80, and the origin should be at 80 and 0 point, and the radius, yeah, you have sigma x 100 and sigma average 80, 20 squared plus tau xy is 80, 48 square, and you do square root and you get 52. Yeah, this is our famous ratio 5, 12, 13 ratio. Yeah, I think you must be familiar with this ratio back in Pythagoras theorem in high school or freshman years. Okay, so when you do 5 square plus 12 square, it becomes same as 13 square, and if you multiply some numbers to 5, 12, 13, and you're gonna get this interesting result. I think you multiply factor of 4 here. Okay, then the ratio is the same. Okay, so this is typical way of making problems. When professors make some problem, they want to give you some answers in simple numbers, and they typically use this famous ratio 5, 12, 13, or 3, 4, 5 frequently. Okay, so anyway, after identifying the Mohr circle out of x point, y point, and origin point. Okay, x point is 148, y point is 60, negative 48, and origin is here. And because you rotate the coordinate by 30 degree, you have to rotate 60 degree to obtain the reading of stress component at x prime y prime coordinate system. And x prime gives you sigma x prime minus tau x prime y prime, and y prime gives you sigma y prime and tau x prime y prime. And how can we find the readings? Yeah, from simple geometry. Okay, how can we do that? Yeah, we begin from 80 here. Yeah, the horizontal component is 80 here, and you know the r. Okay, and if you subtract, this is r times cosine 52 degree. Okay, so the reading sigma x prime must be 80 minus r cosine 52 degree. And regarding the negative tau xy, negative tau x prime y prime equals to be same as r times sine 52 degree. Yeah, that's negative tau x prime y prime. Okay, so from here, and if you plug in the numbers, yeah, r equals to be 52. Yeah, of course, to obtaining cosine 52 degree and sine 52 degree, yeah, we need computers or calculators. After plug in numbers, yeah, you obtain 48.4 and 41.3, and which gives you the reading sigma x prime, the reading negative tau x prime y prime. Okay, and in addition to that, because the average stress is preserved under coordinate rotation, yeah, this is something we discussed in previous lecture. Yeah, we can obtain sigma x y prime very easily because we already know sigma x, we already know sigma y. We now just obtain the sigma x prime, which is 48.4. You can obtain sigma y prime relatively easily. Okay, so you obtain sigma x prime, sigma y prime, tau x prime, y prime, which has these numbers, and this is the reading with respect to x prime y coordinate system, which is rotated by 30 degree from original coordinate system. Okay, so with that, I gave you two typical example problems you're gonna see as a homework and final exam. Okay, so in the problems typically ask either principal stress and maximum shear stress, or they give you the rotated coordinate system, and given this rotated coordinate system, they ask you what is the stress component readings. Okay, so with that, let me finish the video lecture for second topic of today.